Welcome to Homework Lib.
Since we have a radical isolated, to find x, I would square both sides of the equation. On the left, that just becomes 2x minus 1. On the right, it becomes a little more complicated. One pattern for squaring a binomial is that you square the first term, which would be, I'll write it out in full, the square root of x minus 1 squared um, plus you'll multiply and double. So the product is the square root of x minus 1, because 1 times the square root of x minus 1, and then double that would be 2 times the square root of x minus 1, and then square the second term. 1 squared is 1. If I lost you there, all I'm really doing is a shortcut for squaring, which is defined as multiplying by itself. So you have the square root of x minus 1 times the square root of x minus 1, which is the square root of x minus 1 squared, plus the square root of x minus 1, plus the square root of x minus 1. So we have 2 of them, plus 1 times 1, which is 1. Okay, now where do we go from here? The square root of x minus 1 squared is x minus 1. Now let's clean this up a bit on the right-hand side. The ones will cancel out. Negative 1 and a positive 1, so we have x plus 2 times the square root of x minus 1. We want to isolate this radical, so subtract x to both sides means we have x minus 1 equals 2 times the square root of x minus 1. Divide both sides by 2, and now x minus 1 over 2 is equal to the square root of x minus 1, and we're going to square both sides of the equation again. That way on the right-hand side we just get x minus 1, and on the left-hand side we're going to get, again, the definition of squaring is multiplying things by themselves. So multiply the numerators. X minus 1 times x minus 1 is x squared minus 2x plus 1 over 2 times 2 is 4. When you multiply fractions, you multiply straight across. Now multiply both sides of the equation by 4, and we'll get x squared minus 2x plus 1 equals, distribute the 4x minus 4. We have a quadratic. Let's set it equal to 0 on the right-hand side. So subtract 4x to both sides, add 4 to both sides. And now this is something we can factor. What multiplies to 5 and adds to negative 6? A negative 5 and a negative 1 multiply to 5, and they add to negative 6. By the zero factor theorem, then x minus 5 is equal to 0, or x minus 1 is equal to 0. So x is equal to 5 and x is equal to 1. We would want to check from the original problem that neither 5 nor 1 would be a problem. And they look like they would be okay. So the solution is x is 5 and x is 1. Actually, upon just looking a little further, you should check your answer. So we think x is a potential solution, so that'd be 2 times 5 minus 1 equals the square root of 5 minus 1 plus 1. Well, 2 times 5 is 10 minus 1 is 9, and square root of 9 is 3. 5 minus 1 is 4, square root of 4 is 2, plus 1 is 3. So 5 does check out. Check the 1, that would be the square root of 2 times 1 minus 1, and the square root of 1 minus 1 plus 1. Well, 2 times 1 is 1 minus 1. 2 times 1 is 2 minus 1 is 1, and the square root of 1 is 1. And we get the square root of 0 plus 1, which is 1, and that checks out as well. Okay?